everyone. We're going to start with lesson 84, and this is Algebra 1. And I'm going to also go through a lot of the problems during the homework assignment because we need to do some review. I think some of our brains have gone to mush, and we don't want that. So I'll be doing quite a few of the problems with you and hopefully giving you a good idea as to how that rolls. 84 is how I usually say, this is a hard lesson, this is not a hard lesson. This one is not a hard lesson. So the good news is that if you can remember some of the things that we did with fractions and radicals, we're kind of putting that together. So we're going to go ahead and get started. Hopefully you've printed your notes. You can find a link to that underneath the video, and should have a PDF file, and you can print that out. Obviously, different printers are going to have different qualities, so sorry for you OCD people, because like for me, my printer did the graph very dark, and it made it really tough for me. So we're just going to have to live with it, and I know you can struggle through it along with me. Alrighty, let's get started. Multiplication of radicals. We already know that the order of factors, ooh, that was kind of messy, but you heard my word there. The order of factors does not affect the product. So we can multiply in any order, which we've already been doing that. We've done that with all sorts of things since about 3rd or 4th grade math. We can also add in any order, but for today we're just multiplying. So you can multiply in any order, and so that means that we can rearrange the factors when we multiply. So 2 times 3 is the same as 3 times 2. We're going to use that type of thing soon. Because of the product of square roots, oops, rule, we have learned in the past that we can separate a radical expression into something that's a perfect square that can be square rooted easily, and another factor that cannot be easily square rooted. And that's what we worked on. I don't remember the lesson number, but it was not too long ago. So we were doing that type of thing. So if it were, say, square root of 50, we could separate that into square root of 25 and the square root of 2. Square root of 25 gets to come out of the radical and become 5, and square root of 2 has to stay. So that's what we were doing before. Now we're going to level up. We're going to do that, plus we're going to be multiplying other things. So when multiplying radicals, we multiply the numbers that are on the outside of the radical sign, and then we multiply the numbers that are on the inside. So it's similar to our fractions, so to speak, because we would multiply the numerators straight across, and then we'd multiply the denominators straight across. Well, with radicals, we multiply the number on the outside and then the number on the inside. So we have quite a few examples here, which are always nice. You can go back to them. 4 times square root of 3 times 3 times square root of 2. Multiply the numbers on the outside. 4 times 3, 12. And then the numbers on the inside. 3 times 2, 6. Then we look at this number here, make sure that we can't separate it into a perfect square and another factor, which we can't. And so that's our answer. 12 times square root of 6. So what you could also do, and if it helps, you could actually write 4 times 3 times square root of 3 times square root of 2. And this is where that stuff in the very beginning, that's why we can rearrange things. So most of you are not going to need to rewrite it like that, but that's how that works. So onward. 4 times the square root of 3 times 6 times square root of 6. We could write it just like we did back here on example 1, or we could just go ahead and do the multiplication. 4 times 6 is, you got that, 24. And then 3 times 6 is square root of 18. Now, that would not be my answer because it needs to be reduced. So I would get it wrong if I left it that way. So square root of 18 becomes square root of 9 times the square root of 2. And hopefully you'll remember how to do that. And those factors, square root of 9 being a perfect square, that number gets to come out of the radical, and it is a 3. So 24 times 3, if you can't do that in your head, feel free to use the side of your paper as scratch paper, because I like to do that too. 72. 24 times 3 is 72, so our answer is 72 times the square root of 2. And that's that. So, not too crazy. And lots of examples so that you can see the different ways to do this. Obviously here with the parentheses, we got to get rid of parentheses first because of PEMDAS. Parentheses go away. So this gets multiplied by the first term inside the parentheses, and then the 4 square root of 3 gets multiplied by the second term. So I'm going to go ahead and multiply those. 4 times 5 is 20. Square root of 3 times square root of 2 is square root of 6. And then plus, because these are both positive, 4 times 6 is 24. Square root of 3 times square root of 3 is square root of 9, or as you will get to be a lot quicker at this, you could always say that the square root of something times the same square root is going to just come out of the radical. So I could have just written 3 right there if I wanted to. So square root of 6 cannot be reduced any further. Square root of 9 is a 3. We already found out from the last example that 24 times 3 is 72. So I'm going to write 20 square root of 6 plus 72. Are they like terms? No, not like terms. So I will circle my answer because that's it. Simple as that. So here, another example. This one may confuse some people because it doesn't have a square root, but you just multiply it as if it were a 1 or square root of 1 or something like that. So 4 times 3 is 12. Square root of 2 times square root of 2. I told you in the last example you could just write that it's 2, or you could put square root of 4 and reduce it to 2 if you'd like. But I like to combine steps as much as I can. 4 times 5 is 20. And my square root of 2 times square root of 1, or whatever you want to imagine that might be. Well, you can't imagine it to be just anything. You got to make it a square root of 1 if you're going to make something. Okay, 12 times 2 is 24. And we know that square root of 2 needs a calculator, and we're not going to use calculator because we don't in Algebra 1, do we? So we just leave it in simplified radical form. That's what it's called. So 24 plus 20, square root of 2. So that's that part of the lesson. Pretty easy, nothing too crazy. The second part of the lesson talks about functions, and I've already told you a lot about the function being a machine. And so a function is one of those machines you put something in and something else comes out. And so it's a number function machine. So we're going to write this here. We can think of an algebraic function as a machine. The function machine will take the number that we input and give a number as the output. So we've already talked about this in previous lessons. Should be review for you. A function. This is a definition. Every member is paired with exactly one second member. So every number that goes in has to have a partner, so to speak. Now here's the next question. For it to be a function, we already learned from, I think it was lesson 84, or I'm sorry, 83 or 82, about how you can't have a vertical line go through the graph and have 2 points that would be on the graph for it to be a function. So it all has to be this horizontal movement back and forth. So we're going to put down here that the domain does not have duplicate outcomes for members. So if you put 1 into the machine, you can't get 3 and 4 out of it. So the domain, being the x, what goes into the machine, can have only one thing that comes out. Duplicate members of the range, however, can have corresponding members in the domain, which would happen if you had a 9 being the answer, the output of your machine, but -3 and +3 being both the domain, because it would be x squared, for instance. So -3 squared is +9, +3 squared is +9 as well. So as long as your domain is a different number, no duplicates, that's good. The range can have duplicates all over the place. That's not a problem. So here, does the diagram represent a function? Here's the domain on the left, 4, 5, 6, and our range is 7, 2, 14. So each of these has an arrow that corresponds from the domain to the range. Is that a function? Yes, it is, because each number that's the domain has a number that corresponds to it in the range. Next example, we want to know if that one represents a function. So we put y in and we get p out. I know, haha, funny. We put a in and we get x coming out, and then m, we get x and 5 as the outputs. Does that make it a function? No, it doesn't, because of the fact that back in the notes, the domain does not have duplicate outcomes. So when I put an m in, I can only get one thing that comes out of it for it to be a function. So nope, no function. Wrong. Okay. The pictures are a little bit easier than all these lists of numbers. So the numbers, you just kind of have to sort through them. The x is the domain, remember, the y is the range. So does either of these sets of ordered pairs shown below designate a function? Well, here we have 4, 7, and 4. You might say, well, this 4 is twice. Does that work? Well, because it's a 6 one time and a 5 another time, then no, it doesn't work. This is not a function. Cannot be a function, because you can't put 4 in and get 6 one time and get 5 another time for it to be a function. However, if it's in the list and it's a multiple listing, like if this said 4, 6, the 0.46, then it could be still a function. It just means that the graph of it comes back to that same point again, and we'll get to that in our list here. So here we've got 4, 15, and 11 as our domain, 8, 6, and 7 as our range. Is that a function? Sure is, because each of these are different than each other, and if it was the same, it has well, I'll show you in the next. I'm not going to go into that right now. Okay, so that is a function. Down here is the one where I was wanting to show this to you. Look at this list on C. I'm going to jump ahead. Which of the following sets are functions? Here's the 0.43, and then here's the 0.43. Does that still make it a function if everything else works? Yes, because it can be listed multiple times. That's not a problem. It just can't have 4 as being the x and then something different. If it's repeated, that's certainly fine. So C is a function. A. Is A a function? Look at the numbers here. What do you think? Yep, it passes our test. B. We have 1, 2, 1, 4. Now we go back to the duplicates, 1, 1. One time we put 1 in and we get 2 coming out. One time we put 1 in and we get 3 coming out. Does that work? No. That is not a function. And then this last one, 1, 4, -1, 3. So we're just focusing on the domain, really. And there's no duplicates, so we're good to go. That's a function. Ta-da! That's basically what we're talking about. Nothing too scary, nothing too crazy. We're just definitely going to be focusing on review now. That's the big part, because these little things that were added to are not too crazy, but now here comes the real brain work. So fasten your seatbelts, stick your helmets on, get ready to go. Here we've got, remember that the number here tells us what lesson we're talking about. So this whole front page is from this lesson that we just went over. So you should be able to do this pretty easily. Feel free to pause at any time and work these problems. Work them and then look at them and see how it goes in the video. That's one advantage that you have to being able to pause me. And hopefully you won't fast forward me. So I really hope that doesn't happen. But if you do that, just don't let me know, please. Okay. So here, 5 square root of 12 and 4 square root of 3. Some of you might say, well, I could reduce this right now. Don't worry about it, because you might as well multiply first and then reduce it. So 5 times 4 is 20. And then our square root of 12 times square root of 3 is the square root of 36. Wow, that's kind of handy because look at there, that's a perfect square. And so I get 20 times 6, which is 120. And that's how that works. So nice and easy. You just basically have to make sure that you don't forget to reduce. Make sure that you're reducing. Okay, distributing here. So 3 times 4 is 12, and square root of 2 times square root of 3 is square root of 6. And then I've got both positives here, so I'm going to add to that 3 times 5, which is 15, and square root of 2 times square root of 6, which is square root of 12. And I can already tell that these graph lines are going to be a big problem. So I will work on trying to get a lighter copy so that even if you have dark ones, they won't be quite so distracting for you to watch on the video, because this is super distracting for me. Are these like terms? No, I cannot add them yet, but I have to reduce this anyway. So I'm going to put 12 square root of 6, and then I'm going to put 15 times the square root of, I'm going to break this into 2 factors, one being a perfect square and one not. So I have 4 and 3. Hopefully this is coming back to you and you're remembering how to do this. So I've got 12 square root of 6 minus, oh, sorry, that's a plus. Oh boy. 15 times 2 times square root of 3. And some of you don't have to write all of these steps out, and that's okay. Now the question is, can I add those? Are they like terms? Nope. That's my answer. Okay. So remember, if you have any questions on these, make sure that you get into the Discord room and whatever that's called. You know me, I'm not exactly sure about all the technical terms, but it's down in the description of the video, and you can make sure that you ask your questions, or you can always text me, and I'm not going to give that on YouTube, so you're going to have to know that already. And no problem, you can text me and ask your question to me there. Okay, following sets 2, 1, 2. Yes, we have a duplicate. Is it a function? No, because we can't put 2 in and get 1 out one time and 2 out another time. So that's not a function. Okay, how about this one? 1, 1, 2. Okay, we've got a duplicate. Now it's a full duplicate of that 0.12 and the 0.12 again. So yes, it's a function. And then over here, you should be able to figure that out on your own. I'm not going to give that to you. And same thing with this one. So I'm not going to give you all the answers. I know. So you're like, oh man. Alrighty. So number 4, we look at the arrows here and we think, uh-oh, they didn't put an arrow there. M doesn't have anything. Oh no, it doesn't have a friend. So can we put M in and have absolutely nothing happen and it be a function? No, because then it wouldn't be a machine. The machine would be broken and the M would just be stuck inside the machine. So we can't do that. So that's a no. That's a no bueno. Alrighty. Now here on number 5, can we have all of them be put in as different numbers and all of them come out to be the same answer? Yeah, we actually could have something like that. And so this could be a function. On this one though, can we put in a 1 and sometimes get a 3 and sometimes get a 4? Nope, we certainly cannot. Not for it to be a function. We could have that in other things, but not for function. All right, then we get into some serious review here. Piggy bank, coins. You remember all of this? I sure hope you do. It's subscripted variables, and so hopefully it's not going to make your brain hurt too much. Excuse me. The piggy bank was opened and it had 475 cents. Remember, we were going to say it in cents, in nickels and pennies, and there were 175 coins in all. How many were nickels and how many were pennies? So we have the number of pennies and the number of nickels, but then we also have the value of them. So I'm going to do the number of them first because it's almost always easier, and I like to. So you don't have to, but if you want to do that way, that's fine. All right, so I have the number of nickels plus the number of pennies, and that's going to equal, not the value, it's going to equal the number of coins I have, 175. I have two variables, so therefore I have to have at least two equations. So my second equation is going to have to do with this value here. It adds up to 475 cents. So I can write that 475 because we don't like decimals very much, and so we're going to change it all to cents. So how many cents are in a nickel? There are 5. So 5 times the number of nickels plus, nice one here because pennies are worth 1 cent each, so you don't need to put the 1 there. You can just leave it. You can put the 1 there if you want to. It doesn't matter. It's not going to hurt anything. Now, you may say substitution would be an easy way to do this, or elimination. I'm looking at this and thinking, if I just subtract this second equation from the first one, I'm going to be able to get rid of my n sub p. So the way that we've done this in the past is we multiply everything times -1. And then this equation right here changes to -5 n sub n minus, oh, I need a different mechanical pencil, I can tell already. These leads are so thin, but it's all right. It's kind of entertaining, huh? And I'm already messing this up. Sorry about that. Okay. N sub p equals -475. And I'm just going to write the first equation just so that you can see it. And then I just add them because I'm algebraically adding, which is also looking a lot like subtraction. So 1 minus 5 is -4 n sub n. And now I have this +1 minus 1, and that's why those go away. 175 minus 475 is -300. And you may start to think, well, wait a minute, I've got negative money, that can't happen. I'm just going to ditch the whole problem. Nope, you can't do that because, thank you, I have now a better pencil. We are going to wait until the very end. If you get a negative answer at the end, then you're in trouble. But you're not in trouble yet, because here's a -4. We're going to divide both sides by -4, and negative divided by negative becomes positive. We're good to go. Bada boom, bada bing. So the number of nickels is a number that you're going to figure out, and then you're going to put that back into one of your equations and come up with the number of pennies. I also noticed that some of you are getting these wrong, and it could be because you're not checking and seeing if those numbers could actually work. Just stick them back in. You can always check your answers that way, and they should work back in your equations. So your number of nickels, and then you're going to also solve for the number of pennies. So you'll have two answers. Make sure that you write them both down. All right, the nickels and dimes all fell on the floor. Oh no. There were 12 more nickels than dimes, and the total value of the coins was 510 cents, or $5.10. How many nickels and how many dimes were on the floor? Oh my. So we have the number of nickels plus the number of dimes, or wait, maybe we're not, because we don't know how many there were total. We just know that there were 12 more nickels than dimes. So I'm not going to add 12 if there were 12 more. I would subtract 12 from however many there were, and that would equal the number of dimes. Okie dokie. That's a tricky one there. You may have to read that a couple of times and think about it. If I had 15 nickels, there would be 12 more nickels than there were dimes, and so I would have to have 3 dimes and 15 nickels. So make sure that you kind of like think that through when you're doing your equations. Now, the value one is going to be easy because we have already been doing that before. So nickels are 5 cents each. Excuse me. 5 times the number of nickels plus 10 times the number of dimes. Oops. ND is going to be 510 cents. And I'm going to look at this and I'm going to think, well, I could do elimination, but substitution is right here. I've got a chunk right there. I can put it in for that n sub d, and I will be ready to go. So substitution is going to be the best way to go. on this one, you're welcome to do elimination. You're just going to have to rearrange an equation and then multiply and then all the other steps. So put that chunk in here. So we have 5 n sub n, and then this piece is going to go into here. So it's plus 10, and then in parentheses we have n sub n minus 12 equals 510. So all I did was I took this n sub d and substituted in the equation. So then I'm simply going to get rid of the parentheses and solve for my n sub n. Then I'm going to put that back in, probably here because that's the easiest. Subtract 12 from it, and that'll give me how many dimes. So again, I'm not going to give you the answers. I just got you very close. So, alrighty. Number 9. This is the ones that we did in lesson 82, and you don't really come up with a number answer. You're taking this piece here, putting it in for x into your function. So you're putting a plus 1 into the machine, and then you're writing down what comes after that, what becomes of it. So I have 2, and then my x squared is the a plus 1 squared minus 3 times a plus 1 plus 2, and then I have to do FOIL right there. So remember, a plus 1 squared is a plus 1 times a plus 1, and then I have to take that times 2. So some of you can do this in your head. I love that when you can. So here I've got a squared plus 2a plus 1, and then I'm taking that times 2. So I just kind of wrote my work down that way, and now I'm going to write it over here. 2a squared plus 4a plus 2, and then I'm going to pick up the rest of my equation right here, minus 3a plus, nope, it's minus 3, and then plus 2, and then I'm going to just keep on going. So I'm putting an equal sign, but it's not really what you're thinking. You're not going to have a equals a number. It's just the process here. Now I'm going to combine any like terms that I have. I don't have an a squared, but I do have a. So I have 4a minus 3a, and that equals 1a. And then I have 2 plus 2 and a minus 3 in there. So 2 minus 3 is negative 1, plus 2 is positive 1. And that, my dear students, is your answer. All right. Also, in lesson 82, we did these cool functions, and we wrote down these cool fancy descriptions of them. And so remember, domain is the x values going this way, and the range is the y values going this way. So we're simply finding the numbers, the lowest number that the domain could be and the highest number that the domain could be. Everything else is written for you. So this shouldn't be too hard. I need you to look back at your lesson 82 notes and your examples if you have questions, but I'm confident that you can do this. And same thing with number 11. We've already done some of this in the word problems, so I have full confidence that you can do this on your own too. And so that will be probably an elimination. I will give you that one as a tip for number 11. Your top equation would be multiplied by either negative 3 or positive 3 or negative 2 or positive 2. You can do it a whole bunch of different ways. Just remember, you got to eliminate a variable. So look back at lesson 67 if you have questions on that. All right, number 12. Some of you are still having lots of trouble with these, with your scientific notations. And so I want you to remember what I told you that one of the students had told me last year. Cool idea, when you're moving the decimal to the right with scientific notation, you're thinking of it as the opposite of the number line. So if you're moving to the right, it's going to be negative. And if you're moving to the left, it's going to be positive. So for instance, here, I'm moving this to the right 1, 2, 3, 4 places. Remember, I have to have a number that's between 1 and 10. And so I need it to be 3.2. And I'm moving it 3 places, 1, 2, 3, no, I'm moving it 4, sorry, 1, 2, 3, 4 places to the right. And remember, it's not positive because it's on the opposite of a number line, so I'm going to make that negative 9. Yeah. And then here I've got 1, 2, 3 places to the left, and I'm going to make this exponent bigger. So I'm going positive. So 4 times 10 to the, that's now at 7, 8, 9, 10. 10 to the 10. Nice. And then same thing with this. 1, 2, 3, 4, 5. 1.6 times 10 to the 5th. And 1, 2, 3, 4, 5. 2 times 10 to the negative 5th. All right. So again, look at lesson 80 if you're still having struggles with this. 3.2 times 4. Or if you look at these numbers here, you could think of these as fractions. 3.2 over 1.6, you should kind of be able to see that that's a 2. Because if the decimals weren't there, it would be 32 over 16. 16 plus 16 is 32. That decimal just goes easily right in there. So I can reduce these, like this part and this part separately if I want to, because I don't like this 3.2 times 4 stuff and 1.6 times 2 and then dividing. I'm just going to look at these patterns. So you can decide how you want to do that. Again, look at lesson 80 if you're still struggling with how to do this. So I'm going to look at this. 3.2 over 1.6 is 2. 10 to the negative 9th over 10 to the 5th. Now remember, I can move this up and it becomes negative 5. So that would be 10 to the negative 14th. And then 4 over 2, that's 2. This is going to be a lot easier than dealing with all those decimals. 10 to the 10th over 10 to the negative 5th is 10 to the 15th, because the negative 5, when it moves up here, it becomes positive 5 and it adds to that. So this is a lot easier to do. 2 times 2 is 4. 10 to the negative 14th times 10 to the 15th becomes just 10 to the first. So you could put that. That would be technically scientific notation. Or if you would like, it does say simplify. So yeah, leave it in scientific notation. I know some of you are tempted to just write 40 because it's 4 times 10. But that would technically not be scientific notation. So just leave it like that. Okay, these other problems here, these are from quite a while ago. And so I'm pretty confident that you're going to be able to do these without my help. And just feel free to ask me, though. I'm definitely willing to do this. So what you're going to do is you're going to take a picture of the problem that you've already attempted. So for instance, number 15, don't just go, I have no idea how to do this, I'm just going to ask for help. Or you could go back to your notes on 78, and the suggestion is multiply both sides by the least common multiple of the denominators so that we can get rid of the fractions. And then looking through your notes, you'd be like, oh, yeah, maybe I'll try to multiply both sides times 12 and see what happens there. And then if you get stuck, then ask for help. So make sure that you attempt these problems and things like that. Remember 16, you've got a lot more going on than FOIL, so you're going to have a lot more terms to deal with. But I have confidence that this will come back to you. Your brains won't be quite so foggy that you won't be able to do this, and you got this. So welcome, and I'm excited for you. Just please let me know if I can help you. See you later.